We will now use the definition of the logarithm to solve logarithmic equations. Again, solving just means we have to isolate our x. So in example A, we have log base 5 of x is equal to negative 3. In order to isolate my x, what I'm going to do is just switch it to its exponential form. So the base here is 5. So 5. I go to the other side to get the negative 3, and that would be equal to x. And again, well, we've solved it already. X is equal to 5 to the negative 3. Of course, using properties of exponents, this is the same thing as 1 over 5 to the third, or x is equal to 1 over 125. In example B, very similar approach. We have x to the 3 equals to 1,000. So again, writing that now. The base here is x, and then we have 3, we got that from the other side, is equal to 1,000. Oh, well now this is a cubic function that I can now work with other ways of solving it. By taking the cube root of both sides, I find that x is equal to 10. Notice that I don't need plus or minus here because it is a odd powered radical. And don't let this, in the last example, don't let this quadratic input to the logarithmic function intimidate you. It's just a composition of functions. Same process. The base is 2. So we have 2, go to the other side, get 1. And that's equal to x squared minus 6x plus 10. 2 to the 1 is just 2. So to solve this, I'm going to add 2 to both sides. And then we have x squared. Well, excuse me, I don't want to add 2 to both sides. I want to subtract 2 from both sides. So this gives me x squared minus 6x plus 8 equals 0. And then, well, we have to factor this. So this gives you x, and then the factors of 8 that add to negative 6 are negative 2 and negative 4. That's equal to 0. So we have x is equal to 2 and x is equal to 4. And what I will say on these examples, you definitely want to check your answers because we cannot deal with negatives inside of here as mentioned in the example. And well, let's see what happens when we check these. When I go ahead and plug it in, I have log base 2 of 2 squared, which is 4, negative 6 times 2, which is negative 12, then plus 10, and we have to decide if that's equal to 1. So simplifying this, log base 2 of 2 to the 10, or 2 minus 12 is minus 8, add 10 is 2, and is that equal to 1? Not quite sure yet. Again, we can convert it to its exponential form and check it, and we would find actually that this does check out. But we'll get some better properties to simplify this on the next page. So that right there was our check of 2. And now let's check 4. So we have log base 2 of 4, this quantity right here. So 4 squared is 16. Minus 6 times 4 is minus 24. Then we add 10, and we have to decide, is this equal to 1? So we have 16 plus 10, which is 26, minus 24 is 2. So again, we have log base 2, and we have to decide, is that equal to 1? Well, indeed it is, and we'll now look at how our y in the next example.